Welcome everyone. This is the introductory lecture of numerical analysis of rainfall-induced wave dump instability. As all of you are aware that this lecture is a part of the online courses offered by Pedazoom. Now in our present course, the objective is to develop a comprehensive understanding about the wave dump instability in mining. Now the wave dump, in our case, we will be necessarily understanding the dumps which are within and outside the domain of the main premise of the mining area. That is, we call the inside dump and the outside dump. Now in our case, as in all cases of numerical analysis, the fundamental understanding of the problem, the modeling and the analysis of the result will be of enormous importance. In our case, instability necessarily means kinematic instability. As you are all aware, after the bench failure, the famous bench failure of Rajmahal open cast mine in ECL, Coal India, the stir, it created an enormous stir that most of the people are thinking that this is one of the most important area which we need to address. Although this problem was a very pertinent problem, but right now an enormous amount of energy, manpower and money has been invested into this problem. In our course, the objective is not only to find out the problem area and their remedies in relation to the wave dump instability, but also we will be concentrating on a particular type of wave dump failure which has been or will be caused by heavy rainfall. All of you must be aware of the fact that due to the change of significant and exponential changes in the climate pattern in South Asia and Southeast Asia, the timing of rainy season, monsoon, and the amount of rainfall in the monsoon has been changed enormously, and this change has definitely affected the stability problem of the wave dump. Now in this case, in this lecture series, we will be trying to address the problem from fundamental principle as in any other numerical analysis, and then we will get into the real life situation with real life data set, real life geometry, real life condition, and we will try to understand that how this can be understood, and not only that, how and in which parameters we have to investigate and we have to put more amount of concentration in order to design wave dump. Now, as this is a numerical problem, numerical area and numerical analysis, and lots of softwares are introduced into it. So definitely we will be discussing the entire thing in relation to a software which will be RS2, which is a platform of rock science. We will be keeping on the two-dimensional cases, and this will be a plane strain analysis problem. But we have to keep one thing in mind, that the wave dump instability problem in mining is of very importance to both the mining engineering community as well as the geotechnical engineering community. So we will be acting as a bridge between these two areas, these two disciplines. But one thing we have to be aware of the fact that this is a real life problem. So we cannot invest or cannot put enough amount of concentration in only the designing the problem, in only thinking about the numerical part of the problem, but also we have to think it in terms of the designing of wave dump and the remedial measure in relation to the rainfall induced instability. In India, surface mining still is growing, and the growth is affecting the amount of wave dump that has been excavated, and not only the volume of the wave dump that has been excavated, not only that, but also where the wave dump will be placed. That means a huge surface area will be required. So that surface area is a very important point in terms of the logistics, planning and project development of the mining. It fetches a huge amount of financial problem. liability to the mining engineering community. So when we will be thinking about the design of the waste dump, we'll have to think it in terms of height mostly, because the surface area will be constrained. So when we will be thinking as the waste dump in a constant surface area, and we'll have to think it in terms of the height, we have to think it in terms of the geometry also. What will be the bench angle, what will be the bench height, how many number of benches will be there, how that benches will be designed, what will be the amount of deck, whether the deck length of the deck will be changing in different benches. These are the questions which are of enormous importance to any practicing mining engineer. As you are all aware, and probably that's why you are here, that Pedazoom has decided that all the courses will be talking about the problem, which is the real life problem, and not only the real life problem but also real life problem which has a huge amount of importance in industry, and that real life problem will be addressed from a very colloquial language of theoretical engineering science. So we'll be talking on these issues. I don't know whether how many of you are aware of myself, whether you are introduced, whether you are you have seen the previous introductory lecture or not. I am Devojyoti Banerjee. I am a junior research fellow in the Department of Mining Engineering of IIST Shibpur. I am doing my PhD under Professor Pratik Datta. I am doing on I am not actually doing my research work in relation to waste dump instability. I am doing my research work in relation to carbon sequestration. But I had my master's thesis in relation, particularly in relation to this area. I'll be sharing what I have learned during the last 1 year of my master's course, and definitely in addition to that, what I have learned from the industry people, what I have learned from them, from the different consultants. Now I would like to introduce you. I would like to start the PowerPoint presentation and the part that you will be learning. In the first slide, there we are trying to make you understand that what is waste, what is a waste dump. Now the problem in the mining waste dump is that it is neither soil nor rock. So it is not in situ rock, not an in situ rock, and at the same time it is not a very fragmented, well graded, well fragmented soil. It's a kind of composite thing of both rock and soil. So it is a very difficult task from a geotechnical engineering point of view to define actually what is the particle size distribution of the waste dump. It is composed of very fine particles of soil and a very huge and composed of with a large size of boulders. Huge size of boulders are there. In fact, this actually depends on the method of working. Whether I am using a very well designed blasting or I am going for machine excavation. Whether I am going for a dragline waste dump or I am going for a conventional shovel dumper waste dump. So method of working also plays a very key role when I am actually thinking in terms of the geotechnical design of the waste dump. Now the next thing is that the water will be percolating through that waste dump. Now percolation of water through the waste dump, in this particular case, we will be considering it as a transient seepage. What is transient seepage? That I will be discussing in the next few slides. But we will be considering it as transient seepage of water through a porous media. So when I am saying, or when I am considering, when I am calling, or when I am naming it as a porous media, we need to keep in mind that that porous media is composed of both saturated and unsaturated domain. So what is it? It's a kinematic instability problem. It's a problem of transient seepage through unsaturated and saturated porous media. Now this kinematic instability has been caused by the reduction of the shear strength of that saturated unsaturated porous media. So you yourself can understand the volume, the stretch, the range of the problem that we will be actually addressing in the coming 1 month or more than 1 month time. Actually it will be of I think it will have 75 days duration. So within within this time range, we will be addressing this amount of difficult problem in this particular course. There will be some homework, and in those homework, all these questions, all these points which we will be discussing right now will be of very, very, very important to all of you.